Three big swings just collided in the robotics world, and if you're paying attention, it feels like the future got yanked a few years forward. Unitree might have just revealed the first serious humanoid robot under $10,000. Elon Musk says Tesla bots, not humans, will walk on Mars first, and he's actually laying out how. Meanwhile, in Germany, Neura Robotics is quietly building cognitive machines from the actuator up with full-body safety systems and cloud-powered reflexes. These stories aren't isolated, they're snapping together into something way bigger. Cheap hardware, real-world smarts, and planetary-scale ambition are starting to align. Here's how. So Unitree first. On May 30th, the Hangzhou crew fired off a single image, just a shadowy silhouette, and the line 26 joint DOF. 6'2 plus 2 plus 5'2 plus 2 coming soon, $1,000. That $1,000 is marketing speak for starts with a single digit, so yeah, everyone read it as under 10 grand. If that sticker holds, we're talking about the first credible research-grade biped in the four-figure range. Unitree's current baby, the G1, lists around $16,000, and the beefy H1 sits closer to $90,000. Sub $10,000 is bonkers. The 26 degree of freedom layout got dissected online within minutes. Humanoid analyst Scott Walter, humanoid bot angelist on X, broke it down like this. Each leg carries 6 axes in a 3-1-2 hip knee ankle setup, complete with a 45-degree anhedral hip, so the robot can swing its thigh without hitting singularities. There's a 2-axis waist that handles yaw and pitch, Z then X in robotics lingo, because Unitree realized the sideways Y twist is basically redundant when the hip itself can roll the pelvis. Arms follow a 3-1-1 plan, 3 degrees of freedom at the shoulder, 1 at the elbow, 1 wrist roll, same as the G1. Finally, a 2-axis neck gives the headpan tilt freedom that the G1 never had. Added up, 12 for the legs, 10 for the arms, 2 for the core, 2 for the head, 26 joints total. Why does that matter? Because extra torso and neck joints let the bot lean, twist, and keep its camera locked on a target while the feet scramble, crucial for real manipulation, not just TikTok dance moves. The waist alone is an upgrade over the G1 single-axis swivel. If Unitree ships that at, say, $9,000, university labs that couldn't afford a GX series Boston Dynamics or even a used industrial arm suddenly get a walking platform with respectable articulation. And Unitree isn't just guessing on leg geometry. Walter pointed out they've settled on non-concentric hip joints, 1-degree knees, and 2-axis ankles, mirroring what Tesla and Figure are doing. The company's video clips already show them leaning heavily on coupled ZX waist motion for dynamic balance. Yaw gets offloaded to the hips and feet. It's a clever way to keep costs down while still letting the torso bend like a spring. Alright, slide over to Texas. 2 days before that Unitree tease, Elon Musk streamed a 42-minute update from Starbase. Say what you will about his timelines, but he laid out a story. Starship could launch an uncrewed flight to Mars in the late 2026 window, reach the red planet roughly 7 to 9 months later in 2027, and the cabin seats will be filled with Tesla Optimus robots, not human. He gave it a 50-50 shot, which for Musk is basically, we're doing it. Ozra News even reported a plan for 5 landing modules, each packed with multiple robots. Why robots first? They eat no air, don't see you over radiation, and they can spend 2 years rearranging cargo in minus 60 degrees Celsius dust storms while the next orbital alignment comes around. Musk name-dropped Arcadia Planitia, the same ice-rich equatorial plane NASA loves, and joked it also happens to be his daughter's name. He wants Optimus units walking around, snapping that lunch atop a skyscraper homage photo, and laying the groundwork for a human base. The long-range math is still insane. Musk talks about 1,000 to 2,000 starships every 26-month window, shipping 1 million tons of kit so Mars can survive even if Earth's supply lines stop. But in the short term, the tech blockers are orbital refueling and that reusable heat shield. The humanoids are almost an afterthought. Still, there's a juicy through line here. Optimus prototypes are rumored to cost high 5 or low 6 figures each. If Unitree really can mass produce a 26 degree of freedom walker at less than $10,000, then Musk's first Mars crew could be running Unitree-grade joints under a Tesla-branded shell. Physical AI scales only when actuators get cheap, and the Hangzhou and Austin roadmaps suddenly look complementary, whether or not they admit it. Deep joints are nice, but cognition is the other half. Enter Neura Robotics. The company popped up in 2019 in Metzingen, Germany, long before the humanoid gold rush, and founder CEO David Reger keeps repeating the same line, physical AI. He just sat down for a marathon podcast with Marwa El-Dawini and Scott Walter where he explained the strategy. Neura doesn't just slap off-the-shelf servos into a torso. They design motors, brakes, cycloidal-based gearboxes, inductive encoders, even force torque sensors all in-house. The result? Their newest actuator doubles torque from roughly 150 newton meters to over 300 newton meters without growing a millimeter. And because they control every tolerance, they can survive a robot faceplant without shredding gears. Their poster child is the 4NE1 humanoid, pronounced 4NE1, standing about 1.80 meters and slated for its Generation 3 reveal at Automatica in Munich, June 24th to 27th. Reger admitted he sized it to roughly the German 50th percentile adult so it can hit factory buttons and door handles without adjustable pedestals. The earlier hand had 6 motorized degrees of freedom. The new one jumps to 16, moving from tendon-pulled fingers to tiny direct drive modules in each phalange. Wrist and ankle share a twin actuator gimbal that favors big downward flexion over upward because, well, humans bend that way too. Throw in a safe human detection sensor, a camera, LiDAR fusion that's SIL rated, and you get a platform that can legally share workspace with people without a cage. Safety is personal for Reger. He's a certified safety engineer and spent years wrestling with the ISO 10218 and ISO 15066 standards that treat collaborative arms like loaded mouse traps. His argument is blunt. Real cobots can't wait to hit a person, then stop. They need to see the person and never touch them in the first place. So, Neura bakes human detection right into the skin, then adds redundancy in the drive chain so a single fault won't send 300 newton meters of torque through your ribcage. They are even modeling controlled falls. Think martial arts break falls rather than rigid timber drops. But cognition is the catch. Neura's secret sauce is the Neuraverse, a cloud plus edge platform where every deployed robot, factory arms, Meeple-wheeled assistants, and soon 4NE1 streams sensory data back into a shared skill store. They teleoperate robots for clean grasp demonstrations, scrape human skeleton motion from depth cameras, and combine that with physics-dense simulation by distributing compute the way biology does. Microcontrollers for reflexes in the actuator, an onboard brain for sub-second planning, cloud LLMs for high-level intent. They hope the hand can react to a slipping bottle before the vision system even knows it's wet. Reger literally calls the actuators little robots inside the robot. That philosophy explains why Neura just launched MIPA, their smartphone with arms on wheels, for about 10,000 euros with a 100 euro pre-order token. Wheels are cheap, stable, and already shipping by the thousand, so Neura can harvest real-world grasp data today while they squeeze weight out of the biped hips tomorrow. Once the leg hardware is crash-proof, the skill set will already exist in the cloud. Scott Walter is heading to Automatica to poke every actuator and gearbox in person, and Neura seems happy to let engineers crawl over the prototypes. They even joked about adding a rotation below the knee in a future build. Nothing's sacred if it gives better workspace. Zoom out and the pattern is obvious. Unitree is attacking cost, Neura is attacking cognition and safety, and Musk is betting that everything will mature just in time for a Mars cargo run. The timelines almost stack. Unitree's cheap walker could hit volume in 2025 to 2026. Neura's 4NE1 learns its first million grasps through Neuraverse, and Starship needs autonomous stevedores by late 2026 to unload those first 5 cargo landers in Arcadia. If the stars and orbital mechanics line up, the first footprints in Martian soil might belong to a swarm of off-the-shelf Chinese joints powered by a German brain, riding a United States rocket. Will it all hold together? Hardware pricing has a nasty way of inflating once real compliance and certification kick in. Musk could miss the launch window if orbital refueling slips even a quarter, and Neura's grand vision hinges on cloud models that still choke on out-of-distribution edge cases. But compared with 5 years ago, the pieces look tantalizingly close. The next hard dates to watch are June 24th in Munich for Neura's Generation 3 reveal, the inevitable Unitree full-spec drop later this summer, and whatever booster-catching stunt SpaceX pulls to validate that 1-hour turnaround promise. Between those events and every podcast Rager records, expect a torrent of new numbers: torque per kilogram, degrees of freedom, price tags, mission mass budgets. Keep your spreadsheet handy. So here's the question. If Unitree hits that sub $10,000 price, Neura nails cognition and safety, and SpaceX sticks the landing, literally, do humans even need to be the first ones on Mars? Let us know what you think in the comments. If this kind of deep dive into the bleeding edge of robotics and space gets your gears turning, make sure to like, subscribe, and turn on notifications so you don't miss the next one. Thanks for watching. See you in the next episode.